Hello guys, welcome to my channel. My name is Isaac JC, and you can call me Bob. I'm a smart contract developer, and I recently started a tutorial on Twitter where I got a lot of advice and DMs that try to encourage me to put out video solutions and tutorial rather. So, and I had to pay attention to all of those messages, and I figured out that I think it's best to start with a video. Though I am not really talking type, and I don't like really talk. I don't like talking, but I just have to do this. So please, you might hear some regularities, you might see some things that are not really cool. But please bear with me. I believe I'll get better, as time goes on. So today we're going to be looking at how we can set up a solidity project. Okay, so this tutorial is not gonna it's not really gonna cover some areas like how to set up a GitHub account, or how to set up a Git bash, all of that. No, we are focusing basically on solidity, though we are still going far. We are still we have a far destination to go. So but starting with solidity, we are going to understand how the contract structure works, how to set up the files and folders, and I will examine some solidity data types, and do some one other things, two things, and that's all for this tutorial. So let's get started. So this is my repository on GitHub. It's my repository on GitHub, and I hope you can see my screen right now. Okay, I think I'm sharing. Okay, think I'm sharing right now. Let me check. Okay, all right, sharing. Okay, so I'm going to create a new repository right now for this tutorial. I'm going to call it Code with Bob. Code with Bob. Okay, so now I just leave the description blank. Let me just use something like hash code with Bob. That one is not really a big deal. We're going to fix those ones later. The repository is public, anyone can access it. And I'm going to add readme. No, let me know how to readme now because of setting up a hardhat project. We're going to be having an issue. I'm not going to add the gtignore. Then I'm just going to choose a license. I'm going to be using the GNU license, then create repository. Okay, so let's wait. Okay, now we have it done. Okay, so what we are going to do now is I have a repository set up, and this is um my project name, and I want to start working on my system. I will call it locally. Okay, as a developer, you'll be working mostly locally on your computer. So we have to clone this. You have to copy this link, click the green button, copy it. Then I have to come here, then have Visual Studio Code here. In this tutorial, I'll be using Visual Studio Code. Okay, you can use editor of your choice. I think there are other editors you can use out there, but I recommend using Visual Studio Code so that you can follow along with this tutorial. So I'll be opening Git Bash. I'll be opening Git Bash. I'll just expand it right now. Okay, so you can see very well. Okay, so this is the home directory. So, and I'm going to navigate into I'm going to clone this project on the desktop. CD. And one good thing about what they call it, about git bash, is that it it allows you to nest arguments and command argument. Okay, or like you can do that in Visual Studio Code. It's not really, that feature is not available, but git bash is handy and helps you. But also git bash has some other side, but we'll get to know as we are coding along. So I'm going to navigate into the my desktop because I want to clone the project on the desktop. Then I am going to say, after getting to the desktop, please create a directory, a new project directory, make directory. Okay, that is the syntax. That's the syntax. Make directory, call it code with Bob. Okay, that's the name. Then after you created it, then I'm going to use the ampersand and okay, you're going to double it. Then after you create that directory, please navigate into a change directory. That's what it means. CD change directory into code with Bob. Okay. Okay, when you now enter the directory, now you can now, I'm going to use the ampersand again. Then you can now git clone. You can now clone the link I just copied. The link I just copied from here. This link here. Okay, then you can now just clone it for me. So for you to paste inside Gitbar, you have to use shift insert. Okay, after you clone it for me, then navigate into that. You clone this repository. Okay, then navigate into the project name for me, which is an cd change directory into code with Bob. So after you enter that directory, which is the last directory we are going to go into, then you open it for me with Visual Studio Code. This is the command code space dot. Then I'm going to run that. So let's wait while that is done. Let's wait. Okay, so we've all right, great. So you can see now that I was able to perform all of these steps just in one line of code instead of having to be doing it one by one by one. So it really helps you to work faster as a developer. Okay, right now what we have here is only the license. We have cloned it and we have navigated into it. So there are just something I have to, there's a concern. You can actually, now we need to set up a hardhat project. So we are going to be using hardhat for this. There are a couple of other frameworks you can use like truffle. Okay, we have I think what's the name of that? Hamri or no, I can't remember. Okay, we have truffle, we have hardhat, we have a few other ones that helps you to bootstrap your solidity project very fast. But I love hardhat, and I really use hardhat a lot. So wait, let's create a hardhat project. No, sorry, npm. We're going to be using the npm package manager. That is node package manager. So you can decide to use any package manager of your choice, like yarn, pmpm, a lot of that. But before I am very engrossed to using yarn because of some issues in lpm, very slow. But nowadays npm is pretty fast, even faster than yarn, and a lot of time I don't get error. So npm install hardhat. I want to use this what do you call it, I want to use this to run my hardhat because it's pretty much slow for me. So let me just use Visual Studio Code terminal. Let me navigate into the terminal. Okay, just close this one, close this for me, close this, stay away. Okay, all right, so you can see now I am in the terminal or the directory already, code with Bob. It's the same directory I have here, code with Bob. Okay, so in this project directory, project root directory, okay, I'm going to install add add okay, sorry, npm install. Now one thing is, before I npm install, let's do something quickly. Let's just initiate an npm project. Npm init dash that, yes, that is the flag. Okay, let's initiate an npm project so you can create the json for us. Okay, package.json where we have all of our packages kept. and every package that we need to use and dependencies are going to be kept inside this package.json. It's a JSON file instruction. What makes it a JSON is this curly brace is just what we call JSON. Everything that inside, everything you need to specify, they reside inside this curly brace. So, and it's a JSON format. So right now we have it done. So let's install that. Okay, npm install that. All right, so let's wait while that is done for us. So while that is coming up, um, you can see now, I want to show you something. Okay, but not now, not now. So I'm not going to be using this, I'm not going to be using this cheat anymore. So I'll just come here. So let's wait. This one is faster than when you have to use Git bash. It really wastes this time so much, and there's not much time. Okay, so while this is running, you can just let me just explain one of few things concerning node module. You can see node underscore module is created for us. Everything you see inside this package.json, every dependencies inside there, there are going to be a dependency, some dependencies here, but not yet installed now. It's going to be installed very soon. So everything is kept inside this node module. You can see now, this thing is installed. For all of these are installed by using the command nps install, and it's going to install everything about hardhat. Okay, because we're trying to install hardhat, and hardhat has a toolbox. So that toolbox is responsible for bootstrapping all of this for us. We'll get to know shortly. Okay, so let's just wait while the installation is completed. And also, we added a license here. It's important that you add a license to your project, and every other thing comes. Yeah. So let's wait while this comes on. My system is a bit slow, so I am not using a sophisticated kind of computer, so please bear with me. Okay, our installation is about to complete. While this is running, you can actually pause this video. I really don't want to pause it because I want you to see everything that's going on. So, and the timing it costs us to, okay, all right, great. So Situa packages are okay, 229 packages were added. Okay, all right. So now everything is installed for us, but not everything at the same time. So right now you can see our node module is done. The package JSON package.lock JSON is created, and the package is now you see that before there was no dependency array dependency that was installed for us inside the package.json. Now we have dependency installed, which is the hardhat. So we are going to use npm to install now. Npm install. It will install every dependencies that is connected to hardhat that is to be used. Okay, so every this node module is updated right now. You can see the green side, the green ones are added right now by using npm install. Okay, now let's get started. Now for us to get started with hardhat, we need to instantiate an hardhat project. Now we only install hardhat, but not hardhat project is created. So we need to create a hardhat project, and here is a command to do that. Here is a command to do that. npx hardhat, npx hardhat, npx hardhat. So let me do something for you. Let me do something for you. That same command I used, let me use it inside git bash, so that you see what I was talking about, the error you might probably get. Npx hardhat. Let's see what it tells us. So you can see the error we got. You are not inside the add that a project and add that fail to initialize a new one. So that's one big issue with Git bash and add that. I don't know how they try to resolve that. But for long, I was effed up, in that mysteries until I had to uncover it myself. While I was troubleshooting, then I just started using Visual Studio Code. So right now I'm going to close Git bash. So let us initialize this project. Let's initialize it. Let's set up our hardhat project. Okay, so now we're going to be using JavaScript project for now. JavaScript project. Then our project is going to be created in this directory. This is where our project will reside on our computer. Okay, so I click OK. Then to create a git ignore for us. Okay, all right. So you need to install this dependency to run the simple a sample project. So these are the dependency we need to run now. npm install save that, add that, blah blah blah. Okay, let's copy that. Let's copy that and paste here. Okay, then it's okay. And let's wait while that is installed for us. Okay, let me minimize this now. All right, so while that is installing, let me explain a few things. Now we have our structure created for us. A simple add that project is created. We have the contract folder, we have the node module folder, the script, the test. So for the beginners, a lot of us maybe don't understand what files and folders are. Let me quickly explain. Folders are like a list. Okay, and inside folders there we have files. Okay, so files exist inside folders just like a parent-child relationship. So the folders are parents to the files. So there can be many files. Even folders can have many folders, okay, inside of them. So inside this node module now, you can see we have different folders. Folders you can always expand. Anytime you see this arrow sign, you can expand them. It's a folder. Okay, it's a directory or a folder. So inside the folder you can have files. You can see all of these. You don't have this kind of symbol, so they are files. Okay, all right, so that's how it works. Then we have the script folder created for us. In that script folder we have the deploy.js, which helps us to deploy our smart contract. Okay, to either testnet on mainnet or wherever we want to send it to. Then we have the test file that enables us to write custom tests for our smart contract. Then now we have a file called gitignore. Inside this gitignore, everything you see inside there, the node modules, there are huge files inside the node module. Each files, in fact, there are very much inside each of these folders. There are a lot of files, so we cannot, and the size are much, so we cannot commit all of this on the GitHub. Okay, so that is why we need a gitignore file. Everything inside the gitignore file is not committed or sent or pushed to your repository. They can never be committed. So because might be some sensitive informations that you don't want to commit, like the .env contains sensitive information, so you don't have to push to your GitHub. So you just include it inside the gitignore. Then we have the configuration file, the add that config file. You can see that we import dynamic foundation add that toolbox like I told you the other time. Here it contains almost everything that we need, and we have the solidity version specified here for us. But for this tutorial, I am going to be changing this version of solidity. Let me just leave it this way, and we are going to do setup later in the next lesson. Then we have the license, the package location. I've explained that, and then we have the readme also, which contain a simple hardhat commands to run some command argument on your contract. You can add that help to see some help here to test your contract and every other thing. Okay, all right. So right now we have all the dependencies installed in our system locally. Now let us go to the business of the day. We have our contract file, so that folder, Then we have the lock.sol file. This is a sample contract, a sample solidity contract, okay? But we're not going to be using it because we want to create something of our own from the scratch, okay? So right now, I am going to be changing this log.so. Let me leave it that way. Let me just create a new file, a new solidity file called file structure, okay? File structure.so. Though this file structure enables, so what are we doing with this file structure? We want to understand solidity file structure and how you can create one and simple contract skeleton. And one thing is very important when you create, when you are starting your project. From the top of the file, you have to specify the license. And this is how we specify the license. You have to use this double slash or a comment or a double, but most time the double slash is enough. Then you have to say spdx license, capital, that's uppercase, license identifier. It comes in camel case, identifier, then a colon, then you specify the license you are using. So here we have this license here, GNU. So we are going to say we are using GNU license. Okay, all right. Then secondly, you have to specify the pragma version. Pragma, and this is the syntax. You see, we have the linter or Peter is trying to suggest what we are trying to type for us. Okay, so we'll come back to that later. Pragma solidity. Okay, you can see like when I click OK tab, you see it created this for us. Okay, you see almost the same thing we did up there, but it said list, but we didn't specify the license for us. So I'm just that is just going to cut that out. So now pragma solidity, then the version number you are using, you want to use to compile your solidity. This is actually the compiler version. We're going to say 0.0.17. Okay, just as what we have in our configuration file. Okay, because this will be used no matter what you specify here. Okay, this is what will be used to compile your contract. This is what will be used, except if you change the global variable. Okay, so right now people made some mistake. They use this caret. Okay, there's a name they call it. It can give you some errors if you don't really take care. Okay, because when you this caret means you are specified the range of version to use from 0.17, that is, to 0.9. That is what it means. So when compiler is trying to compile here, it started using versions from this 0.3.7, and if the one you need to use is not available, you can get error in some places and you can really run into some troubles. But it's always good to specify the actual, to be explicit by removing this caret, and just say, okay, I'm using this single version. Okay, that's what it means. So right now we are going to create a simple contract. And like I told you on the, for those who read what I posted on Twitter, if you don't, if you have not seen that, I will drop the link in the description so that you can go over it again. Contract is like an object, okay? But in Solidity, we have what we call a keyword, contract keyword, okay? This contract keyword tests you that you want to test Solidity or VS Code that you want to create a Solidity contract, okay? So contracts, then followed by the name of the contract, which is an identifier. We call it my, it has to begin with uppercase. Please note, uppercase. It has to start with a capital letter. My what's the name we give? File structure. Okay, let's call it file structure. Okay, then that is the name of the contract, then followed by a curly brace. Okay, all right, so let me explain this. This contract is a keyword. You have to specify this, you cannot change that. Then this file structure can be any name you care about, or the name of, depending on the contract you're trying to create. But in this tutorial, we are creating a contract called file structure. Okay, then this file structure simply means a placeholder for everything, every logic that will be inside this curly brace, because you're going to be deploying it on the EVM or in the machine somewhere else. So that whenever it is deployed, it's just the concept of variable that is applied here. Everything we do most times in programming has to do with variable, because you are creating a reference to your program somewhere, a reference to your data somewhere, a reference to whatever you are defining somewhere. Okay, in the EVM, file structure is going to be representing your contract. It's going to be hash everything, compile and hash, and give you a contract address. Okay, then this curly brace is just like a block, just like a group, something that groups related settings together. That means this curly brace is engulfing everything that's inside there, and is assigning it to this file structure. So this file structure is a name, okay, that has everything that is inside here. Okay, everything that is inside here, and you can actually, everything inside here is a member of what, of this file structure. So you can actually in another contract, you can access everything that is inside this place using the concept of programming, which is dots. You can use this file structure called dots. You can use the dot member, okay, dot access at the access operator or something. You can use it to access everything that's inside here that are actually public, or you are allowed to be accessed. Okay, all right. So now let's proceed. Now we want to create some basic, we want to understand some things that are supposed to be inside smart contract. And if you want to understand more about solidity, I will leave the link to the solidity's documentation. So let me see if I can get it here. Solidity documentation. Solidity. Okay. All right. So I'm going to be copy this link for you. I drop it in the description. So the just acquaint yourself here. You can see a lot of more. You can read more, get more understanding about solidity concepts here. What I'm doing is I'm just breaking it down from the ground up for you. The foundational knowledge and some things that are not really explained inside the documentation to a concise level for you. Okay, that is what I am also doing here. And please, I hope that you follow along. So let me just keep the readme, the readme. I'm going to keep this here later for use. All right. So inside our file structure, let us understand some data types, data that can be input, that can be defined inside this smart contract. We can define data like unsigned integer. Let's say now we want to create, before we start creating our atomizing our file structure or data, let's understand that we can create what we call unsigned integer or unit. Unsigned integer, well, uint 256. Okay, starting from uint 8. Okay, uint 8, uint 16, uint 8, uint 16, uint 16, 16, or 24, or 24, or 32, or 48, and so on and so forth. But basically, a lot of time have no I don't use different version of this data type. I just use the 256, and sometimes unit 8, 32, and all of that, but not really all of them that I use. But it's good that you understand that all of this exists. So right now we can create an unsigned integer call, and when you don't specify anything here, it means it is defaulting to unsigned integer 256. So we can now say unsigned integer, let's say counter. let's call it a counter that, okay, whenever we create a file, we can count. We used to this to represent the counting, the amount of file that we have created. Okay, all right. So on your file, and your contract can also contain data type called enum. Enum. In this enum, it's just like a you are specifying, you are defining the kind of stages of how things happen from one stage to another. Okay, you can call it folder. Let me say folder, enum folder. Okay, inside this enum folder, remember that I told you that a folder contains many files. Okay, many files. Okay, so I can now say inside this folder we can have folder one. When you divide inside the anything you define inside it, thing should be in capital letter, and they are always converted to integer. Integer. Everything inside this curly brace are converted to integer. Okay, so folder one, folder two, and so on and so forth. Okay, so let me now say the another enum called file. File, you can have file one, file two, file three, and so on and so forth. Okay, so those are the kind of data you can specify inside your smart contract. You can specify enum value. Then also remember that you can also specify what we call a custom error. Custom error. Okay, these are new solidity inversion now that it lets you specify a custom error which also accepts arguments instead of using the string error return. So I can call it that, okay, whenever we are creating a file and there's no file found, and we cannot find any file, you are trying to search a file and there is no file available, then let's return a custom error called file not found. Okay, file not found. So that is a custom error. Then you can also define what we call custom event, sorry, not custom event, an event. So whenever a file is created, you want to alert the user or the front end that a file has been created. Okay, file created, file created. Okay, all right. So this, whenever a file created, you want to specify, you want to return some arguments. Let's say you want to say, okay, a file is created. Let's say the number of files that are already in the system now. They will represent it with unsigned integer. Okay, all right. Unsigned integer. Then we give it a name called let's say files. Okay, created files or whichever one, created files and so on. Then if file is not found, we are going to return an error or error. Okay, this file we are trying to search does not exist. So let's use an assigned integer to represent it. That okay, file number or file name or whichever one is not does not exist. Okay, as in let's use the word actual. Let's just use actual. Okay, all right. So now the other data you can also specify here, you can also use in your smart contract. You have a data type called address. Okay, address is a byte 32 kind of data. Okay, by 32 size. So it's always it's always start with ox, something like this. If you are yes, you should understand how things work on the Ethereum. Okay, so that is how address formats looks like. Address, let's say, okay, we are defining the owner of this contract. Let's give it a name called owner. Okay, the owner of this contract. Then anybody can see the owner of this contract. Let's add that possibility that it is public. So by default, if you specify it this way, by default it is private. Okay, but when we had this public, then we are making it available for anyone to access. So this is, we just create a getter function for you that can return this owner. So whenever you call it, it will return this owner for you. Okay, all right. Then other thing you can also specify here is what we call structs. Structs. This is a user defined type. Every other type you are seeing here is their global type, their global type, their global type. Okay, global type in solidity. But this struct enables you as a developer to create your own custom type. That means there are some times you want to work with different data types or group of data that a utility did not provide for you. So you now allow so now say, okay, hey, you can create your own data type, okay, but it has to also follow some the rules of solidity. So that is what the struct represent. Let's call it my my custom data, my custom data. Okay, why the error there? What the error is it giving us? Okay, empty struct is not allowed. Okay, let's just input some data there, my custom data. Let's say, okay, bytes, bytes 32, 32. Let's say we are safe, we are creating a file integrity, integrity. Okay, all right, so the error is gone. Then other data you can specify is called mapping. Mapping. Mapping is a is making of it's like mapping. How can I other English I can use is you are making a reference, a key value pair reference. Okay, a key value pair. That is what mapping is. You are mapping a key to value. That means you are creating a variable called yeah, you call it a name, then that variable is pointing to something which is the value. Okay, the variable is the key, the value, the inside there is a value that is pointing to. Okay, so that is what this mapping means. It just helps you, enables you to create more more custom type. Okay, you're able to create more custom type. You can divide, you can divide. There are a lot of things you can do inside this mapping. I will get to understand why we are as time goes on. Okay, so let's say now we want to create folders and files. Let's now say, okay, this is our file, and each file can be counted in our system. Let's represent that this is how we represent the counter. Okay, unsigned integer. Then it is map. This is the syntax to folder, to folder. Okay, we map it to folder. This is the folder here. These are folders here. So, and this is our counter. Okay, but we're not going to be using this counter name, which is the name. No, we are going to be specifying because utility is statically typed. That means we are going to specify, we are defining ahead. Okay, we are declaring ahead the kind of data that we want to exist inside the storage. That's what this is storage. Actually, this is storage. We are storing something here. Anything key mapping is to storage. Okay, so we call it folders. Call it folders, and by default it is private. So let's make it public so that we can all see it. Okay, all right. So right now um we have a folder created. So we have a key and a value, a key that is mapped. This arrow just means mapping. This arrow means this key, unsigned integer means whenever you call this any data that is an unsigned integer that is defined inside here, it will return a value of this type. Okay, anytime you call a value of this type, which is unsigned integer, to return a value of this type. That is what it is. So let's now create another data called function. Function. That is the main thing in our smart contract that's that manipulates, that moves, that retrieves, and that stores, that help us to what to store data in our smart contract. Enables us to store data, to retrieve, and to manipulate data in our smart contract. So let's give this function a name that, okay, create file. create file. Okay, this contract now, this is the name. This name is reference. Okay, and it's precede this thing, and this brace you see here is a kind of an input container. Okay, it's a way of taking inputs and using working with those inputs. Okay, with inside these functions, then you can now return a value like inputs outputs. Okay, so this one you are seeing here is an input. Okay, then this one you are seeing here return is output. This is an output, this is an input, this is the output. Returns mean returning output. This one is in, taking in inputs. Okay, so let's create what we call specify visibility of for this function. This function now, we want anybody to be able to create a file in our system. Okay, so we are going to make it public. I'm going to make it public that okay, anybody can create file in this system. Okay, so that is all we need for now. And this file, after you create a file, okay, it's going to return something to you that okay, this file is done. Okay, that is bool. That is the data type. And let's I forget here, you can create what we call another data called bool. Bool just means true or false, true or false, true or false. Okay, so let's say bool can create file, can create file. Okay, what this will do is that it will, anytime this variable is true, okay, anybody can create file in our system. But if it is false, then nobody can create file. But you're going to use this as an abstract access restriction, okay, later in the course. Okay, but not now, we're just specifying, looking at the file structure. Okay, we're not going to do much right now. So basically, we are creating a function here. We have created a function here called create file, that whenever you create this function, it creates a new file in this system. Okay, and and we are going to, okay, for now, that is all you need to know now, so that I will not bore you with too much complex stuff. But if I have to go over it again, let me just explain it one more. Like I said initially, that you specify your pragma no, your SPDS license. Okay, the license you are using in this format, then the pragma version, I mean the compiler version you are using to compile everything inside this contract. Everything, every logic you have created here, you want to deploy them on EV, on blockchain, sorry. So you are specifying the version of compiler to use, and you have to ensure you understand this compiler the situation of a thing, how it works. Because if you use if you use an older version of compiler, let me see, I specify 0.5.4 here as an older version. Okay, there are some latest fixtures that are involved that solidity has made, some times ago, that are not compatible with this older version. Okay, so it's always good to use the recent version, because most of them, they are backward compatible. That means they are compatible with the older version, some of them. Okay, but using the older version for the new, for fixtures that are involved, that are available in the new versions, cannot really work, and you are going to get error for that. Like in 0.4 versions are lesser than 0.5 versions, I think. Now you can specify what we call a constructor. Sorry, constructor, constructor, constructor. You can give it public, you can make it public. Okay, so you can see now that I have error here. It's telling me that source require compiler version, current compiler is 0.8.7, the one that we specified inside the config file. inside the config file. And here we are trying to use 0.4. So it's trying to warn us, concerning that. So if we have to do it, then we have to downgrade whatever we have inside the config file. Okay, so that's all about that, and we get to see more of this in the next lesson. So let me just return this back to 0.8.17. Okay, all right, so the error is gone. So right now I'm going to leave the link to this to the repository in the description, so you can just follow along. And if you have any question, please do not hesitate to ask me on Twitter, and I will always attend to your question. So thank you for watching, and thank you for taking out your time, and thank you as you give it some like and you share this among your friends. Let others also, learn from it, and we all can grow together. See you in the next lesson.